We're on page 273. This is part 2. We have already completed on the previous video the whole left-hand side of the page. Now we're going to do the right-hand side of the page, except for we're skipping number 14. So this video will simply actually be numbers 13 and 15. They're pretty tricky though, so watch closely, and I'll do my best to help you. All right, number 13. It says, look for a pattern. Evaluate the expression 6x minus x squared. I'm going to write that over here. 6x minus x squared. For 0, 1, 2, 3, 4, 5, and 6. Use the results to fill in the table and describe any patterns you see. What is that asking you to do? Well, it's actually telling you to do like 6 problems here. It's telling you to take this expression right here and replace x with 0. And then do it a second time, replace x with 1, and so on and so forth. So for example, if I replace x with 0, 6 times 0 is 0, minus 0 squared, and 0 squared is 0, 0 minus 0 is 0. That makes a lot of sense. Let's do the next one. Let's replace x with 1. And then we're going to go back and replace x with 2. So if I replace x with 1, it looks like this. 6 times 1 is 6. And 1 squared, that means 1 times 1. 1 times 1 is 1. 6 minus 1 is 5. That's all we're doing. It's not as hard as it looks. If you think you can do this, go ahead and hit pause and then use the video to check your answers. 6 times 2 is 12. And 2 squared is 4. And 12 minus 4 is 8. And I've got number 3. 6 times 3 is 18. Minus 3 squared, 3 squared is 9. 18 minus 9 is 9. So it kind of appears that the answers just keep getting bigger. I'm not sure what the pattern is though. But actually they don't. Watch. This is where the pattern will start to go back down. 6 times 4 minus 4 squared. 6 times 4 is 24. Minus 4 squared means 4 times 4, that's 16. And 24 minus 16 is 8. Now I wonder if you could examine the table and predict the next answer. It's okay if you can't, but it'd be interesting to see if you could. I'm going to replace x with 5, so I'm going to do 6 times 5, that's 30. And then I'll subtract 5 squared, that's 25. 6 times 5 is 30. And 5 squared means 5 times 5, that's 25. 30 minus 25 is 5. Do you see this pattern? We peaked at 3. And then 2 and 4 each had a value of 8. And 1 and 5 each had a value of 5. What about 6? This is kind of interesting. Watch what the answer is to when we replace x with 6. 6 times 6 and 6 squared. 6 times 6 is 36. And 6 squared is 6 times 6. That's also 36. 36 minus 36 is 0. That's what that meant by describe the pattern. I'll help you with that right now. I'm going to type it just because it's kind of a lot to write. In fact, I'm not going to write too much. But I do want to point out to you that at the very end, when x was equal to 0 and 6, the value was 0. Do you see that? And then when x was equal to 1 and 5, it was 5. When it was 2 and 4, it was 8. And then at when x was 3, it had its highest value of 3. So what can we write here? We could say when x is equal to 0, the expression has a value of 0. It increases the value of the expression increased as x increased up to x equals 3, then it decreased as x increased. When x was equal to 6, the value was 0 again. I don't know if that makes a ton of sense to you. I mean, it's accurate. If it doesn't, I'm sorry. Let's put that right there so you can see it. I'm going to read that to you one more time. When x equals 0, the expression has a value of 0. The value of the expression increased as x increased up to x equals 3. Then it decreased as x increased. When x equaled 6, the value was 0 again. So basically what I'm trying to say is the values started at 0 and then it increased up to when x was equal to 3. Then it decreased back down to 0 again. If you have a different way of writing it, that's totally fine with me. The describing the pattern might not be the important part, but it being able to find out all these numbers right here, that's the important part. All right, let's go to the bottom of the page. We are, again, I'll tell you again, we're skipping number 14. So let's just go ahead to number 15. Number 15 is a little tricky, but we'll figure it out. So the area of a square is given by x to the second power, where x is the length of one side. Mary's original garden was the shape of a square. So before I even read any further, I'm just going to sketch her garden. And the area of this would be found by doing the side lengths times each other. So the area would be x squared. And that makes sense because the area of a rectangle is the length times the width, and in a square, both the length and the width are the same, so they're both x. So instead of doing x times x, we just do x squared. So that's the area of Mary's garden until she doubled it, and that's what it says. She has decided to double the area of her garden. That just means you go like this. Write an expression that represents the area of Mary's new garden. So I think some kids might want to do x to the third power or something like that, but that's not how this works. To get the area of the entire thing, you would do x squared, but then you would just double it. You would have x squared, but then it says she doubled the garden, so it's times 2. And you could put that in parentheses, or you don't have to. And the reason why you don't have to is because you do x squared first anyway. So to find the entire area, you do x squared, and then you would double it. Now we're going to evaluate the expression if the side length of Mary's original garden was 8 feet. So we need to solve. So we're going to go ahead and use this formula, 2x squared, and we're going to replace x with 8. We could do it on our picture right here. What would the area be of Mary's garden if it was 8 times 8? Well, 8 times 8 is 64. And so the area of this one would also be 64, although we're not going to call that 64 plus 64. We're going to call that 64 times 2. So in other words, if you had 2 times 8 squared, well, you do 8 squared first. Actually, that should not look like that. It should look like... Yeah, that's fine. That looked okay, actually. 2 times 8 squared. So you might think to yourself, I need to do times first, but remember in PEMDAS you would do exponents first. See, there's the beginning of PEMDAS. Exponents comes first. So I need to do this first. 8 squared is 64, and then I'm going to double that. 64 times 2 is 128. I'll show you why. 2 times 4 is 8. 2 times 6 is 12. I get 128. The area of Mary's garden after she doubled it is equal to 128 square feet. All right, excellent work. We are done with page 273.